Hi everybody, this is going to be Sound 101. What you should be looking for when you encounter a new system that you've never seen before. This could be an outdoor, really simple system with 5 inputs. It could be a really complicated soundboard. Before you ever encounter the system, what are the concepts you need to know about that you should be looking for? Okay, number 1, power. Everything needs power. Everything we do is electrical when it comes to sound reinforcement. So a soundboard needs power. A keyboard needs power. Speakers often need power. If they're active, they have their own power, they get plugged in. If they are passive, they need to be powered by an amplifier, which is a piece in between the soundboard and the speaker that gives it power. Guitars often have batteries inside them. Drummers need energy drinks. Everything needs power to get it going. So make sure you know how to turn things on. Second thing, mutes. Sometimes we do a lot of stuff and then we realize a channel is muted. Muting means that you have the volume completely off. It's a single push of a button. Usually when a mute button is on, meaning the thing is muted, that light is on. And when the button is off, the light is off, the thing is unmuted. So mutes, make sure you know how to mute and unmute things. Usually every channel on a soundboard has mutes. Now, let's talk about gain and volume. Everything in a sound system is inputs and outputs. A microphone, you sing into a microphone, that's an input. It comes out the other end, that's an output. It goes through a cable, it has an input end and an output end. It goes into the soundboard, that's an input. Well, you can actually control the power of that input using what's called a preamp. That's the thing inside the soundboard that makes things louder. The preamp has a gain. Gain is the receiving input. So you can think of it as the sensitivity on a microphone. So let's look at a soundboard real quick with individual channels. You're wondering what all the rows of knobs are, right? Because the soundboard usually has rows and rows of knobs. And you never know what they do. And there's so many, and you usually don't want to touch any of them because you don't know what they mean. Well, we're going to debunk what they all mean right now. All right, so all of these rows and rows of knobs. Let's take an individual channel. This is an individual input. One microphone plugs in to this. And all you need to worry about is that row to get that thing making sound. All right, so let's just erase the rest of it. I took the time to draw that, now we're erasing it. We're just gonna focus on one channel here. At the very top is going to be a thing called gain. This might also be called trim. All right, let's just separate that. Okay, at the very top is gain. That might also be called trim. Gain is the sensitivity of the input coming in. It's really how much the preamp is receiving that signal. So if you think of a funnel, the simplest form of what we're doing with sound amplification is the sound comes in at one volume and it comes out the other end at another volume. Gain controls the size of the opening of this funnel. If your gain is turned up a lot, that opening is really wide and you're going to be taking in a lot of excess noise that you don't need. Okay, so we want to make sure that gain knob is not too high so that we're only taking in the signal we want. We want to take in this singer, not the singer standing next to them. That's the sensitivity of the microphone, right? So we want it to be small, but as soon as you make it too small, now you're not getting a very strong signal. It's not registering in the system at a very high level. So no matter how much processing you do in the middle, you can't get it to the volume that you want it to be on the other end. Well, that would be too little gain. Okay, so most sound systems have a gain knob. You can control the sensitivity of that input. And they'll usually have like light indicators. It might light up green if you're getting a good signal. It might light up red if you start to clip the signal, meaning distorting it, meaning overriding, overdriving the system with too much input by receiving it with too much gain. So turn it down if it's clipping, turn it up if you're not getting enough. Volume, on the other hand, controls the other end of the funnel. So say you get a good amount of gain, you have a signal coming in, you're getting the right amount of gain for that signal. Well, now you want it to be a certain volume coming out. That's your volume knob. You're making this opening on the other end bigger and smaller, okay? So this is where the top and the bottom of this channel happen. The top is the gain. That's the sensitivity of the input. All this processing happens in the middle, and then the volume on the other end is where it comes out. Now that volume technically is sending it to what we call the main bus, or the main, which is the main speakers. And that will often have its own volume over here, your main volume. You need to know where that is. It controls the overall volume of the system. So for each given channel, you have a bunch of volume knobs, and you're controlling how much of each channel, each instrument is being sent to that main channel. But you're controlling them relative to each other, and then this controls the overall volume of the system. All right? Now, when we talk about EQ, EQ is these knobs in the middle. Basically, you're controlling different frequencies. Sound is frequencies. You have low frequencies and you have high frequencies. Human hearing is about 20 hertz, all the way up to about 20,000 hertz. Some people would say that it's 40,000 hertz, but the reality is, if you put if you were to have a frequency generator and play a sound, you would probably stop hearing the sound at about 17,000 hertz if you have good hearing. Okay, so we're going to think 20,000 to 20,000 hertz. Those are the only frequencies that matter for us. So when you see knobs on a soundboard, you're usually going to see low, mid, and high. That means they have 3 different ranges of frequencies. Low frequencies usually mean around 100 hertz. It could be 80, it could be 75, it could be 150, but 100 hertz is, in my opinion, the most helpful way to think about it, because we can think of frequencies in tens. 100 hertz is lows. 1,000 hertz is what we call mids. Mid frequencies. 1,000 hertz is the most fundamental mid frequency. Now, mid frequencies can be anywhere from like 500 hertz to 8,000 hertz, but all of those would be considered mid frequencies, and the most fundamental mid frequency I would say is around 1,000 hertz. That's where you get that middle scoop, and I'm using this because I am thinking in a particular visual format that we'll explain later. Highs, high frequencies, let's think of those as 10,000 hertz. So we're not even worrying about 20,000 hertz. That's way up there. 10, 12,000 hertz, that's as high as we need to be concerned with. 100, 1,000, 10,000 hertz. Lows, mids, highs. Usually, lows, mids, highs. Usually when you're working with a sound system, you will have 3 knobs. Lows, mids, highs. You might have a second knob for those mids where you can control what frequency, it could be, again, 500 all the way to 8,000, usually like 500 to 3,000 hertz. You control what frequency you're controlling, and then this is essentially the volume of that frequency, turning it up or down. All right, so if you have, let's say, a white knob at the top, followed by 4 blue knobs, and then a volume slider, there's a good chance that the white knob at the top is gain, the volume slider at the bottom is volume, and then you have high, low, mid control, and mid level. Effects are wonderful. We can do reverb, we can do compression, we can do delay. There's lots of effects we can do. For now, we're going to pause on those and think of them as extra. I want to stress that they are not extra. They are fundamental to making things sound natural. Last thing is buses. I mentioned earlier that these volume sliders will send things to the main bus, the main output. That means they're being sent to your main speakers, but oftentimes we have secondary speakers. Secondary speakers meaning wedge monitors on the stage, speakers pointed up at the musicians. Sometimes we have in-ear monitors, which are speakers in the musician's ears. Well, all of those are individual buses. They're individual routes that we're sending the sound out to. The main speaker is one of those routes. That's what the congregation hears. But then monitor 1 is another one. Monitor 2 is another one. Monitor 3 is another one. The YouTube live stream is another one. All of those are buses, routes that we are sending the sound to. So, you need to figure out how your soundboard sends buses, sends signals to buses, controls the volume of buses. Every soundboard is different. You need to be aware of how yours works.